Okay, so these are just extra examples if you wanted to see me go through and name some stuff to get some more practice with it, if you're not feeling great about it, okay? If you'd just like to see it a few more times before you feel comfortable with the material, okay? So the first one here, we have 3 carbons. That's always step 1, and that tells us the beginning. So the prefix that matches 3 is prop. So we're going to have prop, okay? To decide our ending, we need to look at if there are any double or triple bonds. So there are only single bonds here. What ending does that go with? Ane. So this is propane, just like you barbecue with. Okay, that was easy enough. Let's look at the next one. So first things first, always find the longest chain of carbons. Now be careful here. They tried to trick you a little bit, okay? So there are, yes, there's 1, 2, 3, 4, but look at that. This is still part of the same chain. So just because it turns, okay, it's still a continuous chain of carbons. So there are not 4, there are 1, 2, 3, 4, 5. So the beginning name that goes with 5 is pent. Okay, pent. All right. Now, to find the ending, we need to say, are there any double or triple bonds? So, nope, nope. Aha, yes, there is. Okay, so there is a double bond there. So what ending does that mean this is going to have? Pent blank ene. And the blank is for where that double bond is. So to number them, right, if we start here and go 1, 2, 3, 4, 5, then the double bond will be on carbon number 3. See that? 1, 2, 3, 4, 5. If we start over on this end, though, then we'll have 1, 2. Aha, and then the double bond will be on carbon number 2. So that is the lower number, right? Between doing 1, 2, 3 and 1, 2, we should pick the 1, 2. So this would be pent 2-ene. Okay, next one. Always parent chain first, because that will tell you how to start your thing off, right? So on this one, we've got carbon to carbon to carbon to carbon to carbon to carbon. Okay, so 1, 2, 3, 4, 5, 6. So find the beginning that matches with 6, just like a hexagon with 6 sides. Hex is the beginning. Okay, now to figure out the ending, does it have any double or triple bonds? You betcha, right there. That is a triple bond. So this is going to end in "-ine". Now, the last thing we need to say in our name, right? Because if I just told you hexine, what would you all scream at me? You'd all say, yeah, but where's the triple bond? Okay, and so now we can look, now we have to say where the triple bond is. Okay, so it's not enough to just say that there is a triple bond, right? It's like if you all walked in my room and I said, there is a gigantic spider, you would all be just fine with that? No, you would say, where is the gigantic spider? Okay, same thing here. There is a triple bond. Where is the triple bond? It is on carbon number either, I'm going to give you 2 options, carbon 1, 2, 3, 4, 5, 6. So if we go that way, it's on carbon number 5, or we could go this way and it would be carbon number, right? If we go this way, this bottom way, it's going to be on carbon number 1. So should we make it be on carbon number 5 and count this way, or should we make it be on carbon number 1 and count this way? Well, we should always give it the lowest number possible, right? So this would be hex 1-ine, okay? So we shouldn't do this way. Now here's a condensed formula that they've asked us to name, okay? Don't get fooled by this. It's still just a carbon bonded to a carbon bonded to a carbon bonded to a carbon. It's just that they didn't bother writing out where all the H's were, okay? So we still just have carbon to carbon to carbon to carbon, right? That's 4. So what beginning matches with 4? It's bute, okay? Now for our ending, what kinds of bonds do we have? Do we have any doubles or triples? Well, I don't see any. That's a single, single, single. So single bonds, SBs only. Okay, which means what ending does it get? Ane, right? We don't have to say where the double or triple bonds are because there are no double or triple bonds, right? So it's just butane. Easy enough. Okay, let's look at the next one. So how many carbons? 2. So if you find the beginning that matches 2 carbons, it is eth. Okay, any doubles or triple bonds? The only bond there is a double bond. So how does it end? It ends in not ane, but ene, okay? Now, there would be nothing wrong with calling this F1-ene, Okay, that's totally fine. I would never take a mark off for that or anything. We actually don't need to though for this, just because think about it. Is there any other place that double bond could be? No, right? Because there's only one bond anyway. So if it's a double bond, then ethene kind of tells you it is that one. So nothing wrong with this, but the only kind of ethene is F1ene. So we don't need to say it. Okay, now here's a line formula that they've asked us to name. So this has how many carbons? That's what we got to figure out first, right? So this has 1, 2, 3, okay, 4 carbons, right? There's a carbon at the end and at every corner. So 1, 2, 3, 4. What matches with 4? What beginning? Bute matches with 4. And do you see any double or triple bonds? Nope. So this is just going to end in ane. Hey, this is the same thing we just had, just shown a little bit differently. Butane. Okay, here we have, again, let's figure out how many carbons. So we've got 1, 2, 3, 4, 5 carbons. So this is going to start with pent. Okay. Again, page 9 is where I'm getting all these prefixes, right? You don't have to have them memorized. You'll probably get enough practice with them that you start to memorize them by accident, but you don't have to. Okay. Pent. Now, any doubles or triple bonds? Because that's going to tell us the ending. Yep, there's a big old triple bond right there. Okay, so this is going to end in ine. Last thing we have to say is, where is that triple bond? So we have two options. We could number it the way I did here in blue, right? And that would make the triple bond be on carbon number 3. Or if we go the other way, 1, 2, 3, 4, 5. Okay, what's lower, 2 or 3? 2, of course, right? So we should call it pent 2-ine. Always give the double or triple bond the lowest number possible. Okay. So there you might start to see what I mean by why drawing is a little bit easier, because they can't trick you, right? I'm thinking of this one. They can kind of trick you there and make you think, hey, it's only 4 carbons. But when you're drawing, you can't really trick yourself, right? So with that in mind, let's go ahead and try drawing these guys, okay? So first thing they ask us to draw is ethane. So remember, beginning tells us how many carbons, ending tells us what kind of bonds there are in there, either single, double, or triple. And if there's a number, it tells us where the double, triple, or single is. Okay, so let's start with ethane. So eth, what does that tell us? How many carbons? Well, if you look on page 9, you have that. Eth means 2 carbons. So we would have 2 carbons. Start with that. Okay, just single bonds for now. If there's double or triples, we can add them in later. Okay, ethane. So any doubles or triples? Nope. If there was a double, it would be ene. If there was a triple, it would be ine. So all that's left to do, we've dealt with the eth. I kind of go through it with a checklist. Read the name and see if you've told us about everything in there. So have you told us about eth? Yes, 2 carbons. Have you told us about ane? Yep, you just drew single bonds. So now all that's left to do is fill in the hydrogens. So this carbon's making 1 bond. It needs 3 more hydrogens to be happy. Same thing here. There we go. That is ethane. Okay, number 2. So oct. So oct tells us there are 8 carbons. 2, 4, 5, 6, 7, 8. Okay, start there. Any doubles or triples we need to add in? Well, no, because it ends in ane, right? So now ask yourself, have you told us about the oct? Yep, we drew 8 carbons. That tells us oct. Have you told us about the ane? Yep, that's all the single bonds. So if you've told us everything that's in the name, all that's left to do is fill in the hydrogens. So this guy's made 1 bond. It needs to make 3 more with hydrogen. This guy's made 2. Needs to make 2 more with hydrogen. Okay. Same goes for all of these guys. And finally, this guy's only made 1. So to make 4, he needs to make 2, 3, 4. There we go. Octane. Okay, number 3, hex to ene. Number 3, hex to ene. So hex tells us what? Hex tells us 6 carbons. So let's start there. 6 carbons. 1, 2, 3, 4, 5, 6. There we go. Hex has been dealt with. Now we need to deal with ene. Okay. Well, specifically, we need to deal with 2-ene. So we need to put a double bond somewhere. And you're thinking, oh, where do I put it? You put it on carbon number 2. So 1, 2, add a double bond. There we go. Whoops, that looks like a triple. Double bond. Okay. Have we dealt with the hex? Yes. Have we dealt with the 2-ene? Yes. So all that's left to do, we've dealt with everything in the name. All that's left to do is fill in the hydrogens until every carbon is happy. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Hex to ene. Number 4. So propyne, propyne. Okay, prop, start there. Prop means 3 carbons. 1, 2, 3. Now we need to worry about the ine. Okay, they didn't tell us where the ine is. That usually means that there's only one way to write the thing. No matter how you draw it, it's going to be propyne. Okay, let's see if that's true. So we have propyne. So that means one of them is going to be a triple bond. Okay, if let's say we make this one a triple bond, you might be thinking to yourself, how did you know to put it there and not there? Well, let's think about this. If I put it, let's just draw it again. If I put it here, did I really make something different? Notice that if I put it there, we might say it's prop 1-ine, right? But if I put it here, I should start counting this way anyway, right? So this would also be prop 1-ine. So it actually doesn't matter where you put it. There is only one kind of propyne. Okay, so back to doing this one. Have we talked about the prop? Check. 3 carbons. Have we talked about the ine? Check. Triple bond. What's left to do? Make everybody happy with some hydrogens. So 3 bonds, 1 more hydrogen to make 4. This carbon has 1, 2, 3, 4 already. It doesn't need another hydrogen, but this carbon only has 1, so it needs 2, 3, 4. There we go. Propyne. Okay, number 5, pent 1-ene. So first, let's deal with the pent. Pent means 5 carbons. So number 5 is going to have 5 carbons. 1, 2, 3, 4, 5. Okay, there we go. Pent, already dealt with, right? Wasn't so bad. Okay, pent 1-ene. So now we got to deal with the 1-ene. So that means there's a ene means double bond, right? And the 1 tells you which carbon it's on. So on the first carbon, there is a double bond. Have we dealt with the pent? Check. Have we dealt with the 1-ene? Check. What's left to do? Fill in the hydrogens. So 1, 2. This carbon's making 1, 2 bonds. It needs 3, 4 with some hydrogens. 1, 2, 3 for this guy, so it just needs 1 hydrogen. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. There we go. Pent 1-ene. Number 6, methane. So first deal with the meth. Meth means what? Meth actually just means 1 carbon. Have we dealt with the meth? Have we dealt with the ane? Yes, because it doesn't have any double or triple bonds, right? It doesn't have any bonds. Well, it's going to have bonds to hydrogen, but, right? So we've dealt with the meth. We've dealt with the ane. That just means fill it in till it's happy with hydrogens. So 1, 2, 3, 4. Methane. Easy peasy. Okay. Finally, hept. Hept means 7. So let's start there. 7, hept. So 1, 2, 3, 4, 5, 6, 7. Okay, there we go. Hept, check, dealt with already. It's like a nice little checklist we can go through. Now we need to deal with 3-ine. So ine means there's a triple bond, and 3-ine means the triple bond is on the 3rd carbon. So on the 3rd carbon, we have a triple bond. So let's say 1, 2, 3, triple bond. Okay, have we dealt with the hept? Yep, we drew 7 carbons. Have we dealt with the 3-ine? Yep, we put a triple bond on the 3rd carbon. And so all that's left to do is make every carbon happy by filling it in with hydrogens. So 3 for him. 2 for that one. None for this one because it already has 1, 2, 3, 4. None for this one because it already has 1, 2, 3, 4. 2 for this one because it only had 2. Same for this one. And this one has 1, so it needs 3 more. And there we go. Hept 3-ine.